Today, we're going to pull back the curtain on the invisible science that keeps our tallest buildings from falling down. Imagine a huge skyscraper, and it's swaying in an earthquake. Now, how in the world would an engineer figure out the exact stress on one specific beam, buried somewhere deep inside that massive flexing structure? How do engineers guarantee a building will survive something that's almost unimaginable? Imagine the ground starts to rumble. And then, bam, within seconds, a violent earthquake hits. A catastrophic amount of energy is just injected into the building's foundation. We're talking billions of joules here. It's a level of force that's kind of hard to even wrap your head around. Now, the building doesn't just try to stand there stiff as a board. That would be a death sentence. It would just snap. Instead, the whole thing sways. It bends. It flexes. It's basically performing. It's transforming this incredible dance with physics to absorb all that terrifying energy. So, to make any sense of this chaos, engineers don't even try to track every little wobble and shake. Nah. Instead, they start by zooming out, looking at the bigger picture. And this brings us to our first major clue. This idea of total energy. Think about a rubber band. When you stretch it, you're loading it up with potential energy. You can feel that tension, right? Skyscraper is basically just a giant, super complex collection of really, really stiff rubber bands. And the earthquake? That's the force trying to stretch all of them at once. This leads us to a really key concept that engineers use. They call it the energy budget. It's pretty much what it sounds like. The total amount of energy that the earthquake has dumped into the entire structure. And the wild part is they can actually calculate this. They can figure out this one single massive number for the whole building. But hold on. Here's the paradox. Knowing the building's total energy budget seems kind of useless, doesn't it? How does that one giant number for the entire building tell you anything about the specific wobble of one single beam on, say, the 50th floor? This is where the magic happens. It's called Castigliano's theorem. It basically says you can find the exact strain on any single part of a structure using only the total energy of the entire system. It's the bridge. It's what connects the whole building to that one specific beam. Okay, I know that sounds a little abstract, so let's use a brilliant analogy to make this crystal clear. Let's forget about skyscrapers for a second and talk about a grocery bill. So imagine you go to the store and all you know is the final total on your bill. Let's say it's $100. You don't have the itemized receipt. Well, Castigliano's theorem is like a mathematical trick that lets you take that total, that $100, and instantly figure out the price of just the apples. It lets you pull out the value of one single item from the entire sum. And the theorem works the exact same way for a skyscraper. The engineers take the total energy budget, that's the total bill, and they apply the theorem to find the stress on one specific beam. That's the price of the apples. It's such an incredible intellectual leap when you think about it. So why does all this matter? Well, because this isn't just some clever trick. This is the kind of math that actually builds our modern world. I mean, think about it. This theorem is a total game changer. It's what allows for the design of these complex, ambitious, and most importantly, safe structures. So the next time you look up at a towering skyline, just remember that you're not just looking at steel and glass. You're actually seeing the physical proof of an incredibly elegant idea. You're seeing the invisible math that's holding our world together. Hey, if you enjoyed discovering the invisible ideas that shape our world, you know what to do. Make sure to subscribe for more. Thanks for watching.